Hi, I'm Dr. Sam Sunshine, and today I'm going to be talking about COVID-19, giving some updates and talking about ways we can boost our immune system. So let me first start by sharing my screen and we'll get started. So update on the COVID-19 virus and improving immune function, learning to cope and live in a world of uncertainty. As we know, the world is currently battling a global pandemic of SARS-CoV-2, the novel coronavirus that causes COVID-19. At this time, the US population is under semi-quarantine, dubbed social distancing. Most businesses are closed except for essential businesses like hospitals, medical offices, banks and grocery stores, etc. Those who can are working from home. The ultimate goal is to flatten the curve. And what this means is that by social distancing, we decrease the number of people who are being diagnosed and being hospitalized and treated for the COVID-19 virus. By flattening the curve, the outbreak spread would be slowed. And this would help to not overwhelm the hospital system. This quote by Tony Robbins, "Every problem is a gift. Without problems, we would not grow." So where are we now? In the United States, there's been 67,000 deaths and over 1 million confirmed cases. Worldwide, there's been over 244,000 deaths and 3.5 million confirmed cases. This graph to the right is total confirmed COVID cases in the United States. When we look at daily confirmed COVID-19 deaths, are we bending the curve? It looks like it's certainly flattening. These other gray lines are other countries. And you can see flattening and decreasing of the daily confirmed death rates due to COVID-19. So who's at risk for the COVID-19 virus? The overwhelming majority do not have significant risk of dying from COVID-19. A Stanford University antibody study now estimates that the fatality rate, if infected, is likely 0.1 to 0.2%. In New York City, the epicenter of the virus in the United States, the death rate for people under age 18 is 0. The death rate for people between ages 18 and 45 is 0.01%, or 10 in 100,000. The death rate for people over 75 is 0.8%, or 80 times higher than the 18 to 45 group. What about deaths in New York as a state? 2/3 are older than 70, 95% over 50, and 90% had an underlying illness. If we look at the United States as a whole, 99.2% of confirmed COVID-19 deaths had an underlying illness. So who's at risk for hospitalization due to COVID-19? So thus far, New York City has had more than 34,600 hospitalizations. And what they found is that if you're under 18, your risk for hospitalization is 0.01%, or 11 per 100,000. If you're in that age range of 18 to 45, your risk is 0.1%. And if you're between 65 and 74, your risk is 1.7%. What we see is that age by far is the strongest risk factor for hospitalization. According to the World Health Organization, 80% of all cases have been mild. Half of all people testing positive for the COVID-19 virus are asymptomatic. This means no symptoms. And infected, younger, and otherwise healthy people will not need significant medical care, which is a great thing, right? So here's a self-portrait of Van Gogh. So next I'm going to talk about population immunity. And this is where you allow infected people to generate an immune response by coming into contact with others. And they generate antibodies. So let me rephrase that. So this is where infection allows people to generate immune response, and that's developing antibodies. So as infection is controlled throughout the population by what's termed herd immunity. Medical care is not needed in the vast majority of people who are infected in this fashion. Infected people without severe illness are the immediate available vehicle for establishing widespread immunity. This is a good thing. However, extending whole population isolation, like we're doing now in the United States, would directly prevent widespread immunity from developing. So the goal is really to protect the vulnerable, but promote immunity. So promote an isolation policy that protects nursing home residents, the elderly, and patients with chronic health conditions. We want to promote population immunity. Let's open up most workplaces and small businesses. However, maintain large group precautions and allow essential socializing to generate immunity. This is a graph showing COVID-19 testing in the United States. So fortunately, we are seeing an increase in the number of tests that are being done on a daily basis. Contact tracing, I don't have information on that. I just don't know how much we're able to do at this point. So what about drug treatments? Remdesivir is an antiviral agent that has showed some promise. It seems that a 5-day course is similar to 10 days of therapy. It seems to reduce time to recovery. This is a drug that's administered in hospitalized patients. And those who do well seem to recover faster if they're given this drug. Thus far, hydroxychloroquine and chloroquine, the anti-malarial medications, have not shown promise. Non-pharmacologic treatment, the use of gloves and masks, seem to help slow transmission rates. What about vaccine availability? In the United Kingdom, they're developing a vaccine that they think will be available this fall. Others say it may be another 12 to 18 months before we have a vaccine. If the virus has any significant mutation, this could undermine progress. So here's a study that was published in 1920. And I know you can't read that, so I'm enlarging the title of the paper. This was published in a very prestigious journal called The Lancet, called Influenza Pneumonia, the intravenous injection of hydrogen peroxide. So back then, these two doctors, Oliver and Kintab, were trying to save these troops, these British troops, from dying from the Spanish flu of 1918. This was before the advent of antibiotics. They were doing intravenous hydrogen peroxide. What did it show? Encouraged by the apparent success of this case, we tried the method on 24 others, cases of influenza pneumonia, selecting always those whose condition was apparently hopeless. A total of 25 cases, 13 recovered and 12 died, a mortality of 48%. Pretty remarkable. Intravenous hydrogen peroxide will not be used this date, but that was a very interesting paper. And I found that I really didn't know much about the Spanish flu of 1918. So I'm going to talk a little bit about that and how it compares to COVID-19 and the seasonal flu. So first, looking at seasonal influenza. This is what we get every year. This is why we get a vaccine, is to try to prevent the seasonal influenza and the Spanish flu of 1918. So currently, globally, there are about 400,000 annual deaths that occur from the seasonal influenza virus. COVID-19 deaths are currently estimated, this is 231,000 as of April 30th. As of today, it's 244,000. We compare that to the Spanish flu of 1918, 500 million people were infected, roughly 28% of the world population. Interestingly, there were 3 waves to the virus. In the first wave, 3 to 5 million people died. Pretty staggering. In the second wave, 20 to 50 million people died. The death rate from the Spanish flu was 200 times higher than today's influenza death rate. Roughly 1 to 2.7% of the world population at the time died from the Spanish flu. And here's a graph looking at the global numbers of deaths from influenza pandemics over the years. If you look at the very bottom to the left, the typical flu season accounts for 400,000 deaths globally. Above that are the different pandemics that have occurred and their estimates of deaths. When you look at the top in purple, you see the Spanish flu. Over time, there have been 3 estimates. It's kind of hard to go back in time and estimate the number of deaths. Currently, the estimated number of deaths is 17.4 million and dwarfs what we see currently. The Spanish flu had 3 waves. The initial wave started in late June of 1918 and lasted about 6 weeks. Again, 3 to 5 million people died globally. And then in late September, early October, there was a second wave. It was more severe. This was felt to be due to a viral mutation that made the virus more virulent. What that means, it made it more deadly or lethal. And then there was a third wave that started at the end of January, early February of 1919. So compared to the Spanish flu of 1918, is the COVID virus different? Well, they are 2 different types of viruses. They're both RNA viruses, but they differ. The incubation time for influenza for the Spanish flu was 2 days. And for COVID-19, it's 5.5 to 6 days. So longer to develop in the body. When we look at lethality, infants and younger people, the peak age of death in the Spanish flu is 20 to 40 years of age. For COVID-19, it's mostly elderly, again, over 75. When we look at global fatality rate, 2.5 to 5% for the Spanish flu. The seasonal influenza rate is about 0.1. And it is speculated that after we have all the testing and the pandemic has calmed down, COVID-19 will be around 1%. So there's hope. All pandemics do come to an end. Lifting quarantines based on projections of low fatality rates while protecting the vulnerable is the course we should take. It appears that many countries have the situation largely under control. So it's time to boost our immune system and overall health. The quest for certainty blocks the search for meaning. Uncertainty, as in this current pandemic, is the very condition to impel man to unfold his powers. So what can we do to boost our immunity? Well, there's quite a few things that have been shown. Diet, the food we buy, cook, and eat, exercise, sleep, stress reduction, and supplementation. So as not to make this talk too long, I'm really going to be focusing on the final topic here, supplementation, and what's been shown in the literature. I'm going to comment just briefly on nutrition and immunity. So fresh fruits and vegetables, organic, fresh fruits and vegetables are preferred. Those have a lot of the vitamins and nutrients already in it. Foods rich in polyphenols support a healthy immune system. Polyphenols are the substances that give fruits and vegetables their color. You want to avoid inflammatory foods, and sugar tops the list as being the most inflammatory. You also want to avoid highly refined and processed foods. Those are very inflammatory. And limit alcohol. It's also a sugar. And what I have found is that often missing in public health discussions around immunity and infection are the nutritional strategies to support optimal function of the immune system. It's kind of curious. Why is that? What we find is that deficiencies or suboptimal status in micronutrients negatively affect immune function and can decrease our resistance to infections. This is a study that was recently published, or a paper it was titled Optimal Nutritional Status for a Well-Functioning Immune System is an important factor to protect against viral infections. Again, COVID-19 is a viral infection. I highlighted in red, this is the journal Nutrients, and it was published last week. What about exercise? Exercise is near and dear to me. I don't think we exercise enough as a population. I find it, for me, it keeps me alive. So 30 minutes, 5 days a week of moderate intensity exercise is what is recommended by the Surgeon General. Another option is 75 minutes per week of high intensity exercise. A study done in 2000 estimated that about 22% of Americans actually get the minimum requirement. Fortunately, a subsequent study in 2020 estimated that about 32% of Americans are now achieving the minimum requirement. Fortunately, this should be closer to 80 to 90. What are some of the benefits of exercise? Well, we know it reduces your risk of cardiovascular disease, stroke, type 2 diabetes, mental health issues like depression and anxiety, osteoporosis, which is a condition of thinning of the bones, some cancers, and it reduces your risk of death. So when we look at the percentage of physicians, and I threw that in here because I'm a physician and I thought it'd be interesting. This is from statica.com. It's broken into different generations. The millennials, which is in blue, Generation X, black, and the baby boomers in the gray. And so we look at people, the physicians who are only exercising once a week, it's about a quarter. We look at people 2 to 3 times a week, it's about a third. 4 to 5 times a week, which is much better. It's about 20 to 25%. Those who are exercising daily, the baby boomers seem to outperform, 12% versus 7 and 5%. And then those who do not exercise at all, it's sad to say, but it's 10 to 12% of the physician population. What's interesting, this is the J-shaped graph of risk of chronic disease and premature death on the y-axis, and on the x-axis is your fitness level. Now, we do fitness testing in our office. I think it's something that every patient should get on an annual basis. But what this graph shows is that even if you do a little bit of exercise and you improve your fitness from being inactive and unfit to being a slightly more fit, it drops your risk for chronic disease and premature death significantly. And that's really the take-home message. Do a little bit. Here are some references on exercise and immune function. Skip over that. Next, I'm going to talk about sleep. Sleep and its benefits on the immune system is a talk in and of itself. So I'm just going to state a couple facts. One is, before the invention of the light bulb, it was estimated that the average American got 10 hours of sleep per night. In the 1960s, it was estimated that about 3% of the population, small, slept less than 6 hours per night. It's kind of unheard of. Today, about a third of the population sleeps less than 6 hours per night. One of the important things about sleep is developing what's called a circadian rhythm. All plants and animals have a circadian rhythm, except humans. Having a healthy circadian rhythm has been shown to improve immune function. What about stress management? Again, this is a talk in and of itself. I won't go into too much detail here, but there is 2 nervous systems that all humans have. We have a parasympathetic, which is the rest and digest, and we have a sympathetic nervous system, which is the fight or flight freeze nervous system. What we want to do is stimulate as much of the parasympathetic nervous system, this is the vagus nerve, as much as we can from the moment we wake up until the moment we go to bed. We want to avoid stress and negative energy. That's the sympathetic nervous system. Things that stimulate the parasympathetic system are meditation, yoga, and being grateful. So I'm going to spend the rest of this talk talking about supplementation. These are vitamins and minerals we can take. They're often bottled nicely in the store. You can order them online. About 50 to 60% of people take some supplements. I do. I do believe in supplementation. And we're going to look and see if supplementation helps to prevent viruses. What does the data show? So we're going to be looking at these. There are even more. So if people look at this list and they're like, hey, you're forgetting this, this, and this. Yes, there's a plethora of vitamins and minerals that have been shown to be effective. So we're going to talk about these. Again, that's a big undertaking in and of itself, starting with vitamin A. So vitamin A does help protect the epithelium, which is the inner lining and mucous membranes of our digestive tract. It seems to modulate T helper cells, which is part of our immune system, and secretory IgA, one of the main immunoglobulins that helps fight infection in our intestinal tract. We want to use caution in treating children and pregnant women. We want to avoid too high of doses. It is a fat-soluble vitamin, and it can be stored. This study, titled High Level Dietary Vitamin A Enhances T helper type 2 cytokine production and secretory immunoglobulin A response to influenza A virus infection in mice. This was in the Journal of Nutrition 2000. So that's great. It seems to help mice. There are no randomized controlled trials that I was able to see in humans. However, if you are to dose with vitamin A, recommended between 10,000 and 25,000 international units daily to help to support our immune system. What about vitamin C? Wow, a lot of data on vitamin C, as you can imagine. It is an essential micronutrient in humans. Surprisingly, humans are one of the few species that can't manufacture vitamin C. Apparently it requires 4 enzymes, and humans have only 3. Us, the fruit bat, and several species of monkeys are the only ones that can't manufacture vitamin C, so we need it in our diet. Vitamin C, in terms of it affecting our immune system, it seems to accumulate in these specialized cells called phagocytic cells, such as neutrophils, and can enhance chemotaxis and phagocytosis. And these are 2 processes in which we kill bacteria and viruses. Vitamin C supports the epithelial barrier function against pathogens. That's the lining of our digestive tract. And this study, titled Vitamin C and Immune Function, published in Nutrients in 2017, their data suggests that vitamin C appears to be able to both prevent and treat respiratory and systemic infections by enhancing various immune cell functions. Pretty impressive. Dosing is anywhere in their study 100 to 200 milligrams per day. A lot of other people are recommending up to 1 to 3 grams per day. And this should be given in divided doses twice a day. It is a water-soluble vitamin. So here was a huge meta-analysis. This is where you take a bunch of studies on a particular topic and you sift through all the literature and you come up with a position statement based on the findings in these clinical studies. Most of these meta-analysis look at randomized controlled trials where they do compare vitamin C to placebo. And this was a Cochrane collaboration published in 2013 titled Vitamin C for Preventing and Treating the Common Cold. Now again, the common cold is primarily caused by rhinovirus, but the non-novel coronaviruses also play a role in causing the common cold. What did it show? First of all, the objective was to find out whether vitamin C reduces the incidence, the duration, or severity of the common cold when used either as a continuous regular supplement or as a therapy at the onset of cold symptoms. So the author's conclusions were the failure of vitamin C supplementation to reduce the incidence of colds in the general population indicates that routine vitamin C supplementation is not justified. Yet, vitamin C may be useful for people exposed to brief periods of severe physical exercise. Regular supplementation trials have shown that vitamin C reduces the duration of colds, but this was not replicated in the few therapeutic trials that have been carried out. Nevertheless, given the consistent effect of vitamin C on the duration and severity of colds in the regular supplementation studies and the low cost and safety, it may be worthwhile for common cold patients to test on an individual basis whether vitamin C is beneficial for them. So pretty interesting. We do know that vitamin C is very effective for preventing and treating colds in marathon runners and endurance athletes. So fear. So fear is a reaction. Courage is a decision. Winston Churchill. So next we're going to talk about vitamin D. So vitamin D is another often supplemented vitamin. It is the sunshine vitamin. So many immune cells, so these are the cells of our body that fight infection. Many of these cells have vitamin D receptors on the surface. And when vitamin D binds to that cell receptor, it affects that function of that white blood cell. So it does promote differentiation of monocytes into macrophages and increases their killing capacity of viruses, yeasts, and bacteria. We also see a reduction in cytokine expression. Cytokine storm is what's causing the acute respiratory distress syndrome in the COVID-19 patients who have severe symptoms. This is a paper entitled Vitamin D Supplementation to Prevent Acute Respiratory Infections. This was another meta-analysis. Again, a meta-analysis is where you pool a bunch of clinical studies and draw a conclusion. This was published in 2019. Come back to dosing. But what the study selection was, a randomized, double-blind controlled, placebo-controlled trial. So they only looked at those in humans who were supplemented with vitamin D3 or vitamin D2 of any duration and its effect on acute respiratory infection. And their conclusion was vitamin D supplementation was safe and it protected against upper respiratory infections overall. It seems that the patients that were very deficient and those not receiving bolus doses experienced the benefit. Incorporation of additional IPD from ongoing trials in the field has the potential to increase statistical power. Dosing for vitamin D, generally 5,000 IUs daily, which some people would be, wow, that's a lot. The RDA is 400 IUs daily. The other option is 30 minutes of full body sun exposure, being in your board shorts or bikini between the hours of 10 a.m. and 3 p.m. We don't see that so much anymore. So zinc lozenges. There's been a lot of data on zinc lozenges, and the zinc lozenges entered the market in the mid-1980s. In the prestigious journal Nature, zinc was shown to inhibit the replication of rhinovirus. Again, rhinovirus, number one cause of the common cold. In 2010, Dutch and American university researchers showed that a high concentrations of zinc ions coupled with an ionophore, which is a technique to get the zinc into the cell and penetrate that lipid membrane, inhibited replication of the SARS-CoV-1 virus. The evidence is thus very strong that zinc lozenges, if taken early in the course of a viral infection, like the common cold, may shorten the duration by about 33%, pretty significant. Dose, you want it greater than 75 milligrams per day, and you want properly formulated zinc lozenges, usually zinc acetate or zinc gluconate, and only for short-term use, not long-term use. However, there is no evidence to support the efficacy for zinc lozenges against COVID-19. Here are some of the references for the papers on zinc lozenges. So this is a picture of a lady stockpiling toilet paper, and her husband is holding a newspaper that says Dow Market, and he says, that toilet paper you've hoarded is now our 401k. So next we're going to talk about omega-3 fatty acids. A lot of people are very familiar with omega-3 fatty acids. So they usually these are essential fats. Again, these are, anytime you hear the word essential before a vitamin or mineral, it means we don't make it and we need it. So it's essential to us. So we need these molecules. We need the supplement in our system. You can also get it from fish. So if you're eating fish 2 to 3 times a week, that's oftentimes sufficient. But these omega-3 fatty acids usually present at sites of inflammation in our bodies, and they become converted to these pro-resolving mediators. And these SPMs, or pro-resolving mediators, orchestrate the resolution of inflammation and support healing, including in the respiratory tract, it's our lungs. So a number of these pro-resolving mediators have been shown in animal models only to protect against and resolve acute lung injury or acute respiratory distress syndrome. And again, it's this acute respiratory distress syndrome that people who get the SARS-CoV-2 virus are dying from. In this study, titled Immunonutrition for Acute Respiratory Distress Syndrome in Adults, again, another Cochrane database systematic review published in 2019, the author's conclusions were this meta-analysis of 10 studies of varying quality examined effects of omega-3 fatty acids and or antioxidants in adults with acute respiratory distress syndrome. This intervention may produce little or no difference in all-cause mortality between groups. We are uncertain whether immunonutrition with omega-3 fatty acids and antioxidants improves the duration of ventilator days or ICU length of stay or oxygenation at day 4 due to the very low quality of evidence. Adverse events associated with immunonutrition are also uncertain, as confidence intervals include the potential for increased cardiac, gastrointestinal, and total adverse events. So wow, omega-3s for acute respiratory distress syndrome questioned. Next, resveratrol. Resveratrol, another flavonoid antioxidant. It's a naturally occurring polyphenol, shows many beneficial health effects. So what about against viruses? Resveratrol has been shown in vitro, again, that's in a petri dish, to be effective against the MERS-CoV virus. That's the Middle Eastern respiratory virus. In this study, effective inhibition of the MERS-CoV infection by resveratrol. This was published in 2017. The dose that's recommended is 100 to 150 milligrams daily. And in the study, they concluded we first demonstrate that resveratrol is a potent anti-MERS agent in vitro, again, in a petri dish. We perceive that resveratrol can be a potential antiviral agent against MERS-CoV infection in the near future. Unfortunately, no randomized controlled trials in humans. Quercetin, again, another polyphenol flavonoid molecule, has antiviral effects against both RNA and DNA viruses. It also impairs viral protein expressions, and it's one of the most ubiquitous flavonoids and is found in many Chinese herbs, vegetables, and fruits, as well as in red wine. Numerous experiments have been done that show quercetin exerts an anti-proliferative, that's like cell growth, antioxidant, antibacterial, anti-cancer, and antiviral effects. Again, unfortunately, no randomized controlled trials in humans. If you do take quercetin, it's recommended 1 gram twice a day. So BID means twice a day. And lastly, we're going to talk about probiotics. So probiotics are capsules of bacteria. And these are common bacteria that we find in our intestinal tracts. We know the intestinal immune system accounts for about 70% of our immune system. And it's crucial to really protecting the human body from many potential harmful substances that we eat that are in our intestines. Many microorganisms residing in the gastrointestinal tract, again, that's our Digestive tract play an important role in modulating immune responses, super critical. Probiotics may have beneficial health effects by competing with pathogens, again, pathogens or bacteria, viruses, and funguses for substrates, or direct antagonism of pathogens via antimicrobial peptide production. So they have a couple ways of impairing the growth of these pathogens. Here's a study showing the effect of probiotic and prebiotic on immune response to influenza A vaccine in adults. Again, another systematic review, meta-analysis published in the journal Nutrients in 2017. Participants who took probiotics or prebiotics showed significant improvement in the H1N1 strain, that's a flu strain, and seroprotection rate. This meta-analysis suggested that probiotics and prebiotics are effective at elevating immunogenicity or antibodies by influencing seroconversion and seroprotection rates in adults inoculated with influenza vaccines. Pretty impressive. So in summary, with the exception of vitamin C, vitamin D, and zinc, randomized controlled human clinical studies evaluating the benefits of that supplement are non-existent. The benefits of these few supplements are most noticeable in patients who are very deficient in that vitamin or mineral that's being studied. And there are a plethora of elegant cellular and animal studies that evaluate the mechanism of action. And it's a shame that these supplement companies, shy away from doing these randomized controlled trials on their actual products. The good news is, by and large, supplements that have been mentioned today are inexpensive and they're safe to use. But buyer beware. If you have any questions about supplements, please reach out to me and I can help you navigate the supplement landmines. Thank you very much for listening to this Zoom webinar on COVID-19 updates and supplements to help boost our immune system.